Welcome to the CERIAS Computer Security Seminar. Our speaker today is Fariborz Farahmand. He's a faculty fellow in CERIAS, and he will speak on perception and trust in cloud. Fariborz.
Thank you for the introduction. I'm glad to be here. My background is in computer science, and my research is multidisciplinary, and it bridges different areas like computer science, management, information systems, decision science, and sometimes social sciences. My today's presentation is about risk perception and trust in cloud.
Is this seminar?
Yes,
Okay.
your students.
Yes.
Yes, come on in. I believe we should have more. They're coming, yeah. Okay. Okay.
If your name is on there, you can sign it if you're taking a private picture.
Okay, first question of the semester. For those who were here before, what is my name? What is my name? Here you go. Okay, you passed. Okay. So today I'm going to talk about risk perception and trust in cloud. And how many of you are CS majors? Major in computer science? Okay. The presentation that today I'm going to give on cloud, it's going to be a kind of different from the standard traditional presentations that you hear about cloud computing. It's more focused on business side of cloud computing, the challenges that we have, and specifically dealing with the human aspects of cloud computing. It's about the interaction of cloud computing and users, how they interact with each other. And my presentation is divided to 5 parts. Starts with the background and motivation, defining cloud, and then the influence of security, privacy, and trust in cloud computing. At the third part, I will present a risk perception model that we have developed at Purdue. The fourth part is addressing security and privacy risk in cloud. And finally, the fifth part is the conclusion. Okay. We all have heard of cloud computing, or most of us, and we all have heard different definitions. Some people believe, this is just another form of distributed computing that we used to have it for decades. It's nothing real. Some people say, no, it's very different. And at the beginning of this presentation, like many other lectures that you may get, we're supposed to have a definition. Then we move based on that definition. I could not find any definition better than the one provided by NIST. Have you heard of NIST? What is NIST?
I don't know what it stands for.
NIST is National
Institute
Standards and Technology. It's a place that for standards, so we try to follow standard definitions. Would you like to read the definition for us?
A model for enabling.
And you put this figure.
Oh.
Yes.
A model. Push the button. Oh, push the button. Okay. A model for enabling convenient on-demand network access to a shared pool of configurable computing resources, such as networks, servers, storage, applications, services. They can be rapidly provisioned and released with minimal management effort or service provider interaction.
Thank you. So this is the way that NIST, National Institute of Standards and Technology, defined cloud computing. And in the next 40 minutes, whenever I refer to cloud, I'm referring to this cloud. So, using clouds have many advantages and disadvantages for both sides, for users and for vendors. Perhaps the easiest one which comes to your mind is the storage. You have tons of room for storage. And the problem that you have with many other systems, that you get messages that, gosh, this is our code, you have to start deleting some of your files, blah, blah, blah. That doesn't happen with cloud, often at least. So there are many advantages for users and for vendors. And of course, disadvantages, like any other new technology. Again, as I said at the beginning of the presentation, I want to stay focused on the human side of it. And I look at some of what is known as disadvantages or security issues in cloud. Why should users trust? Thank you. Why should users trust a new computing environment, which we call it today cloud computing? Why they should pay money for that? Why they shouldn't stay with their old systems? They were able to afford it, and then they have to go to all this new process of this new computing environment. Why they should do that? Why they should share their personal information in cloud computing, in a technology that is new. We all hear about the security incidents on a daily basis. Why should users do that? Why should they share their private information? These are some very important questions that business people, the people who look at the business side of cloud computing, are dealing with every day. An answer to these questions are essential to investment in cloud computing, and at the higher level, policy issues on allocating resources, how people deal with these new technologies like cloud computing. Cloud computing is a new information technology, it's a new computing technology, but it's still technology. In dealing with many technologies, we have enough information to do what is known as a statistical risk analysis, to look at the data, to do a logic, scientific way of analyzing the information. Example, hopefully you won't get to a car accident. But if you get involved in a car accident, and the car accident is minor, in many cases, it's not even worth it to get an argument with the insurance company. Why? Because based on years and years of incidents, thousands of incidents, they were able to develop such a comprehensive databases which looks like standards. And if you try to continue the case, continue to fight the case, you may end up going to court and you may not even win, because they have all these databases developed in such a long time. We don't have that luxury with cloud computing and information technology in general, because of the age of the technology. It's so young. We don't have data to do the statistical analysis. The other issue is many companies are not willing to release information about the incidents. Why? Because of the reputation, because of the negative publicity. Excuse me. They rather to solve the problem internally than reporting it to the insurance companies. So as a result, us as researchers and industry practitioners are having problem with doing what many other disciplines do. We cannot do a statistical risk analysis. But at the end of the day, we have to make decisions. Decisions are being made on a daily basis. Technologies are being made, they're being sold, and life goes on. So how we do that? This is a quote from Paul Slovic. Paul Slovic is a decision scientist. It's an old definition of risk perception, which still is one of the best. That what is risk perception? Risk perception is practically talking about intuitive risk judgments. That once you don't have enough information to make a scientific analysis of the risk, a statistical analysis, you rely on your intuitions. And these are very important. You make decisions based on perceptions, based on intuitions every day. And it's very important for us as researchers and also for business experts and technologies to understand these perceptions. Why? Because, as Daniel Kahneman argues, Daniel Kahneman is the Nobel laureate in 2002. He won the Nobel Prize in Economics in 2002 for his contribution to psychology and to economics, actually. He started a field which today we know as behavioral economics, which is the application of psychology in economics. And this is what I got from his lecture in 2002 in Sweden. Perceptions, the way you perceive things, lead to intuitive thinking, and intuitive thinking leads to reasoning. How would that happen? A tangible example is getting to the plane or traveling with a car. Statistically, the number of the people who get killed or injured in plane crashes every year is almost nothing compared to the number of the people who get killed or injured in the car accidents, if you look at the numbers. But you know many people, most likely, that when they want to get to the plane, they're kind of uncomfortable, especially when the plane takes off. And I know people who have not traveled by plane in all their life just because they feel it's risky. But they feel much more comfortable with being in the car. Statistically, this doesn't make sense. But why people make these decisions? Because they perceive higher risk in taking the plane rather than the car. And even when they are in the car, regardless of knowing the driving history of the driver, when they are not driving, they don't feel comfortable as much as they are driving the car themselves. So this is a tangible example. This is an example of how perception leads you to think and to make decisions and to reason things. And if you're in business, if people are trying to sell cloud, we have to understand these perceptions. And I'll get back to this plain example later on. So, it's called perception, it's called intuition, but it's actually real. We make decisions on it, based on it. So, can we have a scientific look at risk perception in dealing with technologies. These questions were brought up over 40 years ago by a group of decision scientists, including Slovic and Fischoff in Oregon. At that time, they were dealing with the issue of nuclear power plant incidents. That are we going to have power plant incidents or not? Hopefully we won't. But how people are going to deal with it. And they brought up the question of how safe is safe enough. And answering to this question rely on understanding perceptions of risk. So they were scientists. So they tried to build constructs, dimensions for perceptions of risk. So they defined 9 dimensions for perception of risk that we applied to perception of risk of cloud computing. The first dimension is voluntariness. Does the user use the cloud voluntarily, or he's pushed to use it? It makes it different. If he's being pushed, he perceives higher risk. How immediate is the effect of some incident? Or knowledge about the risk. How much the user knows about the risk of cloud computing. Fourth dimension, knowledge to the science. How much we know about risk of cloud anyway. Control. Do we have control over the cloud risks? And this is the answer to the question of why some people do not feel comfortable with the plane and they try to take the car. The answer is the control. Because once you're sitting in the plane, you don't have control. You are following the pilot, and some people are in somewhere that you don't see. The same thing happens if once you're sitting in the car and you are not driving the car, you don't feel comfortable. So control is one of the dimensions of perception of risk. If you have control, you perceive less risk, regardless of the actual safety of the car or safety of the plane. So it goes on and on, how catastrophic the incident could be, and or how new it is, how common it is, and how severe are the consequences. So these can be applied in understanding perceptions of cloud computing. We can actually model this. We can decompose the risk to these 9 dimensions. So we learned about the dimensions of perception of risk. The same thing for cloud computing. You look at different users, different stakeholders, you're going to have different perspectives. These are just some examples of the stakeholders which are involved in using cloud computing, and they all have different perspectives. The risk to one side is not being considered a risk to the other side. For example, if you are just a user, you care about your personal information. If you are a cloud, if you're implementing the cloud platform, story is different, then the exposure of sensitive information stored on the platform is a big deal. And if you're the organization, you are worried about compliance with all these regulatory agencies. So different perspectives and different perceptions. But we have to understand it. So, risk perceptions that we discussed by Slovic and Fischoff are known as a seminal model. And after 3 decades, people are still using it. But what we looked at it at Purdue was, how about metric? We learned about those dimensions. But how does dimension mean? Can we have some metric? Can we use some metric into this dimension and can have a quantitative understanding of these perceptions? So, over 3 decades, and then in 2010, we estimated that by 80% accuracy, those 9 dimensions can be condensed into 2 dimensions: understanding and the consequences. So, if you are in level 1 and you see the P, the higher consequences you perceive and the less understanding of the risk you have, the higher risk you perceive. And then we introduce ordinal metrics to this dimension. What is ordinal metrics? Ordinal metrics is different from the metrics that we use every day, like ratio. 10 to 5. 10 to 5 is 10 to 2 is 5 times larger than 10 to 1. 5 is 5 times larger than 1. It's the same in the United States, in China, and in Japan, around the world. Everybody would get it. That's ratio. But again, we cannot have that. We can, at least at this time, we cannot use ratio metrics in information security. The alternative we used was ordinal scale. That the level, instead of numbers, we dealt with level. Level 1, level 2, level 3, up to level 5. So level 5 is a higher level than level 4, than level 3. But the level 5 is not 5 times larger than 1. So it's known as a good enough scale. We know it's not perfect, but it's good enough to provide an understanding of the variations. So we didn't want to make it even more complicated. So how to define these levels. So we went back to standards and we used the definition of NIST, National Standard of National Institute of Standard and Technology, which has 5 levels for consequences. Starting from the top, it's low, higher, the highest. If the effects of the incident of cloud are temporary, then the level is 1. And if the effects are catastrophic, permanent, and highly feared, you are in level 5. You perceive level 5. Then we defined 6 levels for understanding. Level 1 is the highest level of understanding. It's opposite. Why? Because understanding and perception are different. The less you understand, the more fear you have. It's like walking in a room that is dark. Because you don't see things, you don't know what's going on, you perceive more fear. So we use the 6th level defined by Bloom, and Bloom is it's famous in assessing students and evaluation. He had the taxonomy introduced actually in '56, which after 5 decades is still well known and very well used. So we use that for the understanding level. This is an example scenario. If something happens to the cloud users, at the beginning, it's going to be at the level 4 and 5 because he doesn't know what had happened. But by the time passes by, he kind of get the situation, so the level get changed. That's the other difference that our model has versus the Fisher and Slovak model. you saw in here that I use the integral and I introduce a time element. Why? Because perceptions are not static, they're dynamic, they change over the time. The way you see things today is definitely different from the way you used to think 15 years ago, assuming that your guys are older than 16 years old. So perceptions change over the time. So we have to understand the dynamism of the model. So that was a risk perception model, and we understood the importance of the perceptions and decisions about cloud. Anybody have any questions so far? All clear? Okay. So we spoke about perceptions, its influence on decisions, and we are back to the cloud. We have to understand the importance of those perceptions and decisions users make about cloud computing. And we have to include them in addressing the challenges that the cloud computing has for us. I kept talking about the user side. Does this mean that the technology is not important? The technical part is not important? Not at all. I did not mean that. What I meant was we have to have an understanding of the users. We just don't build new environments. We just don't build new technologies because we want to have new technologies. We just don't build computers because we want to have computers. We want them to be used by users. And we have to understand that aspect. That's the merit of the talk. So why I think they're important stakeholders, users are important, because if you do not include them in the environment that you are building, then definitely you're going to fail. With technical vulnerabilities, we all have heard of terms like risk-free, which I don't believe in at all. And this is perfect, this is excellent. And you look at this product, you compare it with the other product, they keep throwing things, this is awesome, this is that. If you buy this, this problem will be solved. We have excellent groups of engineers who tested this. And actually, in many scenarios, it is true. They had an excellent test, a group of engineers who tested it. But how they tested it, do we know? What kind of risks they actually looked at? How many of you have heard of penetration testing or target hacking? Yeah. Do we think penetration testing is good enough? Why it's not good enough? Yeah. The same thing. We need to have standards. And even if it includes everything, every aspect, it depends on that person, his knowledge, how he tested it. So we need to have standards for testing technologies. And as I call it here, comprehensive and commonly accepted standards. I believe NIST is trying to develop some standards for this, and some other institutions, but I think this is the need of the hour. And stakeholder involvement. We have to understand their involvement with the cloud and understand their issues. I saw a report that is known as Gartner report. Gartner risks to cloud computing. How many of you have heard of Gartner Group? Okay. What is Gartner Group?
Well, it's they are very well known in technology that they predict the markets and they do a huge analysis. And a lot of
Sorry.
top 100 companies, a lot of Fortune top 100 companies, they usually consult them and depend on their reports. So that's what I know about Gartner Technology Center.
It's very good. They're famous for, our friend said, they're famous for analysis. They're famous for industry standards. That's what they're known for. And what they publish is circulated around many CTOs and CSOs. So this is the 7 risks that Gartner Group has defined specifically to the user side of cloud computing. If you're using cloud computing, according to the Gartner, you're exposed to these 7 risks. The user access, the privileged user access, regulatory compliance, data allocation. For example, do you know where your data is? We don't. This is a risk that it eventually lies on the shoulders of the user. But this is risk. Data segregation. Data versus in cloud computing versus other computing environment is not in one place. It's segmented in different areas. Recovery. Let's say something happened, and things happen all the time. How data should be recovered? From where? By whom? Do we actually know that? We have some ideas, but we don't know exactly. And it leads to the other risk that investigative support. It causes problems in litigations, that all the parties are lost, that whose fault was it anyway? Where did it happen and how did it happen? And long-term viability. How long the data are available. So these 7 risks are the risks that if you're using cloud, it's on your shoulders. Conclusions. You're a businessman, you're a faculty, you're a PhD student, you're a graduate student or undergraduate student, doesn't matter. There are great opportunities for apparently for making money because all these companies are going after it, for PhD students to write dissertation on it, for undergrad to do undergrad research and to publish papers. So there are profound opportunities and many challenges to address. And as you heard today, I'm a computer scientist who looks at human side of technology. I spoke about Kahneman, who won the Nobel Prize in economics, who is actually a psychologist. And I cited papers of decision scientists and social scientists, and I spoke about human interaction. Just hearing what I just said in the last 35-40 minutes, and the number of the people who contributed into this talk and their background tells you how multidisciplinary is the nature of cloud computing's solving approaches. If you are thinking of solving cloud computing, you have to think multidisciplinary. There are many groups involved, many disciplines. And of course, it requires collaborations. Unless you cannot collaborate, you cannot solve the cloud computing problem. You will find piecemeal approaches. You can solve only one part of it, but not the big picture. And you can, if you are working in this area, you can have a great impact. And this is something that we all, if not all, most of us, are dreaming every day. That we want to do some things that can have a good impact on people's life, on technologies. So cloud computing is already in the market. I was reading an article. The guy was the CTO of the company was saying, if you think people in your company, whatever company you are not using cloud computing, you're very wrong. Some of your employees are using it. So it's a reality. It's already there, and solving issues in cloud computing can have a great impact on technologies and on everyday life. Okay. Any question?
Any questions for the speaker? Do you have any answers for the speaker?
Microphone muted. Can you hear the question?
Okay, then let us thank our speaker.
Thank you.